So great, very welcome. I think we can start. My name is Mattias Rotz, and I'm working at the RISE Research Institute of Sweden. And me together with Maria Eblad is hosting this webinar today. And just to mention short words about the BIO2REG project. BIO2REG is a project that is funded by EU under the horizon 2024 to 26 that aims to support regions in transitioning from greenhouse gas intensive economies to bioeconomies model regions. And today we have a very interesting see if I can change the picture here. We have a very interesting webinar with the title of Hydrogen and the Bioeconomy, One Pathway to Solving the Future Energy Solving the Future Energy Challenges. And we are pleased to have participants both from the Research Institute and also from the technology owner with Life, hydrogen producer. And we also have participants from the municipalities with Ånge municipality. And just to mention, we will record this seminar, and please put your question into the chat, and we will try to have a Q&A at the end of this session and try to have a discussion afterwards. So each presenter here will have around 15 minutes, and after that we will have a Q&A at the end of this meeting. And by that said, I think I can let the word over to Anna from RISE, who will start presenting from the RISE or the Research Institute side. So please, Anna, continue.
Thank you. Thank you very much for having giving us the opportunity to be here today and present our highway project, High Coast to West Coast Hydrogen Valley. My name is Anna Sage, and I work as Senior Project Manager at RISE, where I mainly work with EU-funded initiatives supporting the green transition, particularly in the areas of transport, energy, and hydrogen. Highway is Sweden's first hydrogen valley project funded by the EU's Clean Hydrogen Partnership under Horizon Europe. And it places Sweden on the European hydrogen map and connects us directly to the EU strategic initiative to develop regional hydrogen ecosystems. Just some facts about the project itself. The project will run from 2026 to 2031, so it's a 6 years project, and brings together 45 partners from 4 countries, whereas the main part of these partners comes from Sweden, and the project is coordinated by us at RISE. The project aims to establish and scale a dual hydrogen valley in Sweden, and I will come back what we think is a dual hydrogen valley by linking the high coast in the north with the west coast industrial region in the southwest. And our project focuses on renewable hydrogen production, system integration, and real end-use applications across different sectors. And by combining these 2 complementary regions, the project will create a replicable model for hydrogen valleys across Europe. To enable that, we have created something that we call for the transition arena. As system change is complex and requires the coordination along value cycles and across sectors. So we thought that we need something where we can collect all different stakeholders, because no single stakeholder can drive systemic change alone. And as a system level enabler, Highway connects renewable hydrogen production with real industrial applications, including green fertilizer production, bioeconomy integration, energy resilience, and regional industrial transformation. And we will also demonstrate in our project how renewable hydrogen moves from being just a technology discussion to become a functioning regional energy industrial ecosystem. We are collecting under the transition arena the stakeholders in 5 different thematic focuses, forums, and these forums are arenas where you can have pre-commercial discussions. The difference between our regions is actually what we believe the core strength of highway. Industrial demand and the best conditions for hydrogen production are rarely located in the same place, and this is something that we can see across Europe. And we can see this as a challenge, but we see this also as an opportunity. By connecting the strengths of our region or our regions, we can create value that goes far beyond our local context and contributes to Europe's broader hydrogen transition. And our project gives us the platform to do exactly that together. A bit more about the 2 regions that we work with and what we call the dual hydrogen valley concept is that our hydrogen valley, and that might be a bit unique also compared to the other hydrogen valleys so far, is it connects 2 of Sweden's most promising regions for hydrogen development. On one side, we have the high coast in the northeast and the west coast in the southwest. And on the west coast, we already see the largest demand for hydrogen today. This is where major chemical industries and refineries are located. And all of them need to transition towards green and circular feedstocks. However, electricity availability is more limited and costly, which can constrain large-scale hydrogen production. On the other hand, we have the high coast, which offers excellent conditions for large-scale hydrogen production. There's access to land and biogenic CO2, enabling investments at a scale of 100 megawatt and beyond. At the same time, the region faces other challenges such as skilled supply and the need for infrastructure development. By connecting these 2 regions, we combine demand with production potential, and together they form a strong foundation for competitive and sustainable hydrogen development in Sweden. This is just to show what partners we have in the project quickly. So we are 45 partners in the project. And now a bit more before the other 2 speakers come in also, how does hydrogen connect to the bioeconomy? In our project, we demonstrate how renewable hydrogen can connect energy industry and the bioeconomy in one integrated regional system both in the dual hydrogen valleys. And it's mainly by replacing fossil-based hydrogen in applications such as ammonia and fertilizer production. The project supports climate neutral agriculture with strengthening energy resilience and industrial competitiveness. And what makes our project particular is it's taking the system perspective, as I already mentioned, with our transition arena, linking hydrogen production with industrial use, waste heat recovery, transport, e-fuels, and regional value chains. And in that sense, highway is not only about hydrogen production, but about building a more resilient future energy system for Europe. And one of the strongest differentiators of our project is that it's not just an electrolyzer project. It actually integrates the production with industrial use, transport, e-fuels, energy balancing, and waste heat utilization and circular resource flows. We, for example, will use and test or demonstrate residual oxygen from electrolyzers in aquaculture to produce fish, and waste heat will be reused in district heating systems. And with that, I would like to invite you all to follow our journey. And I don't know if we will take questions. I think questions will be towards the end. Thank you. And I think back to you, Matthias. Will you hand over to the next speaker?
I think we can continue then with Christian.
Yes, absolutely. Thank you very much. Thanks for inviting us to speak here today. And looking forward to talk a little bit more about what we do at Life and how that integrates within the bioeconomy. And I will start sharing my presentation here. Just a second. And hopefully there we are. Nope, that's not correct. Sorry, my bad. That should be correct. Okay. Yes. So, sorry, as I said, once again, thank you for inviting me here. My name is Christian Swanson. I'm a business and project developer at Life. We are a hydrogen producer. I will tell you a little bit more about that in just a second. My job is I'm responsible for 2 of our Swedish projects to take them to FID, both from a commercial but also technical point of view in terms of collaborations and partnerships, and as we will come to how to integrate the hydrogen plant into a larger, let's call it industrial symbiosis, because that's what needed to get this type of projects.
I
10
think,
megawatt. Oh, sorry.
Kristen, sorry to interrupt. I think maybe you can repeat the last 2 minutes because it froze.
Oh.
I don't know if it's the internet connection.
About that.
I think it froze again, or was it just
okay.
me?
Okay. Can you guys hear me better now?
Yes.
Oh, fantastic. Okay. We'll simply try again. Okay. Can you see my screen also with the presentation now?
Yes.
Yes, perfectly.
Okay. Well, then good for me. I got a little rehearsal here. Okay. We'll start from the beginning. So, my name is Christian Swanson. I'm a business and project developer for Life. We are a owner and operator and producer of green hydrogen. So our job is to make sure that there are molecules of green hydrogen on the market. I am responsible for 2 of our Swedish projects, for bringing them to investment decision, both from a, let's call it, technical and commercial perspective. So and also working with the partnership and collaborations from a industrial symbiosis point of view, and all of these things that are needed to make these projects fly. And what I was saying was that also to just circle back to what Anna was saying in her presentation just recently. So one of those 2 projects, the Vaggeryd project, as you can see here on the map, is part of the highway project, and there it's a 10 megawatt site with renewable hydrogen production, and it is integrated with a waste heat or district heating plant in the municipality of Vaggeryd, and we will get into a little bit more what that means in terms of integration and bioeconomy. And I mean, it's a very important project for us also from a knowledge and experience sharing with the other production plants within highway, in terms of safety, permit processes, public opinion, and all of the collaborations that we have in there. So it's we're very happy to be part of this project. To give you just a quick introduction to who we are at Life, We were founded in 2017. We're headquartered in Nantes in France. What we do is simply we design, install, and operate green hydrogen production plants. And then we make sure that the molecule is available both for the mobility and industry sector. We see ourselves as pioneers within this field. We had what we would call the first renewable hydrogen plant in the world, and our definition of that is when it's directly connected to a source of renewable energy and producing only with those electrons. We also had the first offshore renewable hydrogen plant that we had a test pilot plant in the Atlantic coast outside of France as well for a year. We currently have 6 sites installed and another 50 megawatts under construction. We're active in 12 countries in Europe, but also in Canada. We are listed on the Euronext in Paris, so we're a publicly traded company, and we basically have, you could say, 2 ways to get to the market with our molecules. It is the bulk model for smaller industrial needs, and but also mainly for the heavy mobility with buses and trucks and or trains. These projects are usually standardized project designs, 5 to 10 megawatts, where we deliver the hydrogen through bulk gas tube trailers of gas. And then we also have the on-site larger projects where we are directly connected to an off-taker in industry. It could be ammonia, methanol, or a steel plant, for example. And these are usually bigger projects. We say that we follow more or less the whole value chain of the hydrogen. We do the development of our projects, we do the permitting, we do the financing, we do the engineering, and for our first batch of projects, we're also the one that have fully built them. So we have been our own turnkey EPC, you could say. And then we keep ownership of the plants and follow through on operations and sales and delivery to the end user of hydrogen. But we do not produce our own energy, so that we cooperate and partner with renewable energy producers, and we also don't own any hydrogen refueling stations. These are our 4 plants that are in operation today. 3 of them are in France, and 1 is in Germany. And we, on top of that, as I said, have another 50 megawatts under construction to soon be online in France. But we're also working on 2 projects in Sweden I will get into in just a second. I think this most of you have most probably seen before, the different use cases for hydrogen, may it be hydrogen-powered vehicles or existing in new industrial applications, either as a fuel or as a raw material in chemical processes. But when we also talk about the bioeconomy, we of course have, when we integrate it with biogenic CO2, or it could also be nitrogen in the case of ammonia to produce e-fuels. But I would like also today to talk a little bit about other ways that you could say that we also integrate hydrogen into the bioeconomy and maybe a little smaller scale when it comes to waste heat recovery mainly. So my entry point to this is that the hydrogen discussion is often dominated by these mega projects, large e-fuel facilities, it's export and shipping, global shipping projects on the gigawatt scale. These are of course extremely important for our energy transition. But I also would like in this case to focus instead on the smaller scale projects that can already today decarbonize local industries and become a very important part of regional industrial symbiosis. It can support district heating, can be integrated into agriculture and with biogas, and in this way create regional resilience. But just so you don't think that I'm completely biased in this, just because I showed you a bunch of small hydrogen projects, we do also work with the big projects. So this is just to give an example of a 100 megawatt project that we hope to take FID on in France this year, in Le Havre. It is one of 2 large-scale electrolysis projects in France that's supported by the government, and it's selected as an IPCEI important project for common European interest. So we do both, but today I would like to focus on our smaller projects in Sweden. So they are called Vaggeryd, as we already talked about in Anna's presentation, but also we have another one in a small place called Jordberga, which is just outside of Trelleborg, which is in the very southern part of Sweden. It's, as I said, close to Trelleborg. It's a major transport hub with the biggest roll-on, roll-off harbor in Scandinavia, where approximately 10% of Swedish export and import passes through every year. Also close to the Öresund Bridge connecting Sweden and Denmark, and also Helsingborg Harbor, where together even more Swedish import-export goes through. Vaggeryd is located near Jönköping, and it's, you could say, basically halfway between the very southern tip of Sweden and Malmö and Stockholm. So there is a lot of logistical centers, and it's also easy access to Gothenburg as the second largest city. What's let's say a common denominator for these 2 projects? It's that they have a strong local political support. Trelleborg has positioned itself as a front runner in green hydrogen, and they are actively supporting our establishment, both where we're building a plant, but also in other collaborations, and making sure that there is also offtake drive in the region, and working as a partner in this. In Vaggeryd, they have a very forward-looking local energy company, Vaggeryd Energy, that ensures we have access to power capacity, but also land, as we are collaborating just next to their plot of land, as I will show you in just a second, and also work together on waste heat recovery from the site. In terms of offtake situation, you see all of these dots here. Those are under construction or planned hydrogen refueling stations in the area. And if you follow Swedish news, you know that since last week there are approximately, I think it's at least 6 more of these now that are colored, as it was a big inauguration of the first 10 refueling stations for one of the major Swedish hydrogen refueling station operators. So it's already now moving forward. For Vaggeryd, this is the district heating plant. We are locating our plant just next door. So what I wanted to say about this, we have our hydrogen production plant, and we will distribute the hydrogen to local industry, mobility, or any other than future use cases. But there is also a nearby pulp mill that is currently providing waste heat to the district heating plant. We will do the same with our low temperature heat, which will be upgraded by heat pump to match the temperature of the local district heating. This will have several advantages. It will reduce the biomass consumption, of course. The more heat we can provide, the less they need to burn. And also the overall system efficiency of using our resources as wisely as we can. But it will also give improved operational efficiency. For example, this district heating plant doesn't operate year-round. In summer, it can be fully taken care of by current and future waste heat. And by adding the hydrogen waste heat into this, that means that they can start their plant later in the fall, and they can keep and they can close it earlier in the spring, I should say. So not only do they save on the biomass, but also in operational and asset management as well of this plant. And naturally, for the hydrogen plant, it means that we have new value streams open up in terms of waste heat, sale of waste heat power. And we also need to cool our plant less with air coolers, so we reduce also our operational costs. So for everyone involved, this is a win-win situation. For Jordberga, which is our plant in the south. It is located in a agricultural landscape. This is an old sugar mill that has been tore down, and now instead we have one of Sweden's largest biogas plants here, which is connected to the natural gas grid. So here we're trying to integrate our plant into the local agricultural system. There is a district heating network also here, which provides heat to a grain dryer, but also to the biogas plant for the hygienization purposes. And we see also future possibilities, for example, for greenhouse heating. We produce some processed water, wastewater, that we're looking into use as irrigation for the surrounding farmland. There is local wind power. There will be local solar power and battery storage. So having a behind-the-meter solution where we only use locally produced hydrogen, locally produced energy as a hybrid park for our plant. And also with the biogas plant, we also, as we said, we have the heat integration, but also one could see a future where we deliver hydrogen to the biogas plant to do together with their biogenic CO2 to produce even more methane, which will then be an e-methane molecule that can be distributed through the natural gas grid. So we are trying to work together with all of the local stakeholders here to create a circular agricultural system. I mean, just to finalize the thought process here, and I think perhaps this is the most important takeaway from these examples, that the future energy system will likely not be built through isolated solutions, but through integration between the sectors. And hydrogen has the potential to act as a connecting link between renewable electricity, industry, agriculture, district heating, and the broader bioeconomy in general. And so when these systems become more integrated, we also create resilience against fossil fuel dependence, resilience against energy price volatility, and resilience through stronger regional and local value chains. So ultimately, hydrogen is not only a decarbonization tool, it can also become an integration and resilience tool. That would be my takeaway from this. So thank you very much for giving me the opportunity to talk a little bit more about our projects, and we'll be happy to answer any questions later on in this presentation. And I think we will also share our contact details later. So I will stop my sharing right now. Okay, thank you very much, and sorry about the technical difficulties here to start off, but I hope we landed somehow on time anyway.
Okay, thank you very much, Christian. And Matthias from Ånge Municipality.
Yes. Sorry, that was not. Try that one again. So thank you very much for having me here at this webinar. My name is Matthias Sundin, and I'm the head of community development in the municipality of Ånge. I will talk a little bit about how that impacts on our daily business in our small community. And I will talk about 3 phases of community development. The municipality of Ånge lies between Trondheim and Sundsvall in a stretch called Mittstråket, which is also a NATO corridor. The midpoint of Sweden lies within our municipality, so we have equally far up to the north as down to the south. We are a small municipality with about 9,000 residents, and we have Sundsvall and Östersund as our nearest towns, some 90 to 100 kilometers in each direction. We also have two major railways that cross each other in Ånge, Mittbanan and Stambanan. And we have one of the biggest railway terminals in Sweden there. We are dependent on the forest. It constitutes about 88% of our land in our municipality, so we have a lot of forests. As I said, we have had 3 phases of development in our municipality. The first phase began in the late 19th century when the railways were built from each direction and crossed in Ånge. That gave us some logistic facts to develop our community. In the beginning of the 20th century, there was also hydropower plants built, and this led to energy-intensive industries being started in Alby and Ljungaverk, in electrochemical, energy-demanding industries. And in these times, the companies built the whole societies. They built schools and housings and shops, and residents in Ånge went from 5,000 people up to 17,000 people in the middle of the 20th century. And the whole society was flourishing during this part of the time. Then phase 2 began somewhere in the 1970s, and it has continued until just recently. During this time, the forestry was mechanized, the industry was automized, it was also moved to other locations due to globalization. Our youth moved due to lack of jobs and a desire for urbanization. And the number of residents decreased from 17,000 down to where we are now at 9,000. Schools were shut down, houses were demolished, and actually some of the people working here had a motto that was to die with dignity. And that is, of course, not so positive. Our third phase just recently began. We now see that we are about in the same place where we were in the beginning of the 20th century. We have a lot of renewable energy, we have a lot of land, and we have great goods logistics, and that makes us attractive to new industries. And we are currently working with establishments in the area of 5 to 7 billion euros, which is about 750,000 euros per resident. And we have set a goal to create more than 1,000 new jobs, and we want to have 2,000 new residents within the next 10 years. The third phase of development started in 2019 when Norra Skog decided to close down a big sawmill in Östavall, which is also in our municipality, leaving about 120 people without a job. The municipality then formed a crisis group together with a business society and started a cooperation that was very successful. Within about a year, almost everyone had gotten new jobs of those that lost their jobs at the sawmill. And as there was a positive momentum, the work was decided to be continued, but now with a focus on the future. And at this time, there were several companies with plans to expand the wind energy production in the region. And together with those, we decided about 3 cornerstones for our future work. And those 3 cornerstones were to attract investments that led to development of local values, primarily new jobs. Instead of producing energy that just gets sent somewhere else, we wanted to produce something from it in our municipality. And the second was to attract new green industry that was going to form itself as cluster symbiosis to use all the waste streams and so on from different processes. And the third was that the focus was going to be on transforming electricity into hydrogen gas and further on to end user products. And this is what we've been working with for the last 5-6 years, and we have come quite a good way. We are actually working with a great deal of the hydrogen value chain today. We are continuously working with increasing the energy production and the grid that is needed for distributing the power. We have a couple of hydrogen industrial sites being planned, and on those we have a variety of different industries, greenhouses, fish farms, biochar, and the end use products that are going to be produced here is aviation fuel and green fertilizers. And we are also looking into the transport and logistics area, since, as Anna said in the beginning, we don't have that much of the end market here in our region, so it needs to be transported somewhere else. And this is our establishment map today. We have two major new grid lines being built through our municipality, and with some transformer station, grid stations that will make for even more industry being able to establish here in our region. We have already today have a new big grid station, which is the number 2 on this map, Tovåsen, that was started in 2024, which is going to have increased capacity in 2028. We have our industrial site in Alby, which is the site that the municipality itself developed, and there we will have the aviation fuel production, but we will also have fish farm, a couple of greenhouses, and a biochar factory. And this site is actually being prepared right now, and the first factory will start to be built next year, and the whole site is planned to be fully operational in about 2030. And we have some additional wind farms. We have a new logistic hub. We have a correctional institution and some other projects as well. So for a small municipality, we have a great deal of things that we are working with right now. Why is Ånge successful right now in this work? I would say that one of the things is that our politicians have dared to say yes to additional power production. Today we have about 140 wind turbines and another 60 being built. And if you look just outside our municipal border, we have about approximately another 100 wind turbines. So when the new wind turbines have been built, we will have a maximum effect from the wind farms with 1,250 megawatts. We also have 13 hydropower stations with an effect about 400 megawatts. In addition, there are 2 large battery storage systems that have been built. We also have a large solar energy park that is in pre-planning. So altogether, this is one of the foundations for the industries that are looking for great places to establish themselves. And I would say another reason why we have succeeded so far is that we all the time search for cooperation, because we're a small municipality with an even smaller organization, so we can't do everything ourselves. So we have tried to join with a business society, with academy, with regional and national government, and we have done some different things. We have a economical association which we work together within. We have had a BIO2REG project with 5 other countries that are towards its end now, and as Anna said, we are now just starting up our new Horizon Hydrogen Valley project with 45 partners. And we have also the universities in Sundsvall and Trondheim are looking to make an BIO2REG project, because there is also a hydrogen valley in the Trøndelag, Norway Trøndelag area. So this has been important for us, and it will still be important for us, because the whole society that needs to be built towards the startup of these industries, that we can't do ourselves either. We need to cooperate with all other parts of society to make this happen. Because this is what we're doing now. We are trying to develop a community that we can welcome up to 2,000 new residents. So we are planning for different kind of housing and increased transport opportunities. And we are working together with the civil society to ensure a variety of leisure activities. We have already built 2 new preschools, and the challenge here is that there are this like 4 or 5 years to where we know that the industries are going to start up and they need their stuff. So it's kind of a short window of opportunity here to make this all happen. So to sum it up, I would say that hydrogen is a key to our development, and we are trying to work in different branches with different kind of industries to have a great variety of jobs to attract people to move to Ånge, because we know that we need people to move in, because we do not have the people that can take all the jobs that are being planned right now. And as a municipality, what we are doing is trying to make this possible to happen by building the society, helping the businesses, and building this symbiosis where the businesses can have as a great output as possible in our community. So I will end there. Thank you very much.
Thank you very much. Very interesting. So I think we have some more minutes here where we can discuss and have some questions. And I will also share this so you can also take contact with the speakers afterwards in case you have any additional question or thoughts. But I can start here, and maybe I can put it like this, and I think you have touched many of the things that when it comes to collaboration and challenges and opportunities. But maybe to start with collaboration, if we start with you, Christian, there, and I think you were into this as well, but how do you really ensure that your hydrogen projects become parts of a regional system rather than isolated standalone projects? And maybe also, how does your ideal partner look like, and what are the critical, which actors are most critical when building a functional hydrogen value chain? So if you can elaborate on that maybe, and I think you touch it also within your presentation. So if we start with you.
Sure. Thank you, Matthias. Yeah, there are a few questions within the question. We'll see if I get all of them here. But I mean, you're like, the key here is, as just you're saying, it is collaboration and it is partnerships, and you have to. I think the main starting point, at least for us, has been we have to see it as partnerships and collaborations. If you see these things as like business transactions, or with a let's call it a like one size pie kind of situation, I don't think you will succeed in getting these projects to the finish line as quickly as we need to do. So, I mean, that has been our starting approach, that, okay, we have to see our partners as real partners. There needs to be a win-win situation. And to be completely frank there, I don't think it's that complicated to find a win-win situations. If we, for example, take like the district heating solution, we have, I mean, waste heat is a valuable product, but it's also an issue for us as a hydrogen producer. We need to pay to get rid of the waste heat by air cooling, and that costs electricity, and we need water and so on. So it's an issue that we have, and then next door we have someone that has an issue. They need to pay for biomass to produce district heating for their local municipality. So I mean, finding these kind of situations and approach that as a collaborative solution to that, because it is kind of a no-brainer. We have to be able to find a solution where both partners get out of that transaction and feel like, okay, we made a win in this situation. So I think that is like the main starting point that we have had. And then of course you have to find the locations that give you that opportunity. I mean, it's producing hydrogen at a competitive cost nowadays is not the easiest and most straightforward tasks. So you need to choose your locations carefully. And I think that's also what Matthias spoke about. Like, you have to find the prerequisites that makes a location suitable for doing this kind of projects. You can't just drop down a standalone asset and expect to create a financially viable project, I say. So yeah.
It's more or less finding industrial or symbiosis in the best way you can, and that is key thing to really see how your technology fits into the system. Is that
and be I would say fast and proactive in working with your partners to ensure that there is a win-win and you can move the projects forward. You can't get too stuck in the transactional discussions either if you want actually to see these assets take physical form as well.
Great. And then Matthias, if we move on to the municipality, I guess in your case it's more to act as a good facilitator and also and how do you attract investments and coordinate with stakeholders and all these things. And I think you also mentioned that within your presentation, so I don't know if you can comment that in some way.
Yeah, it's exactly as we will have been talking about. I think we have been strategic in one way, but we've also been lucky to be able to spread the word about the things that are happening in Ånge. So therefore, we get a lot of businesses asking to establish in our municipality. And what we have been trying to do is to find the right puzzle pieces that fits into our symbiosis clusters, so that we can maximize the effect of the symbiosis and the clusters. We, for example, have a lot, I think many municipalities have that today, a lot of questions from businesses wanting to establish AI data centers. And we have come to the conclusion that is that doesn't fit into our clusters. So we have kindly asked them to look elsewhere instead of trying to squeeze them in. So instead we are focusing on, for example, larger greenhouse businesses, because as Christian said as well, we need to find ways to get rid of the waste energy, the heat that comes from the production of hydrogen gas and aviation fuels, and that greenhouses can be one solution to that. Our problem is that Ånge is not big enough to just use it for district heating. It's just a very small piece of the waste heat that we can use for district heating. So we need to find other ways in our municipality.
Okay, so you have greenhouse products as well then, or?
We are working with, I would say, like 4 or 5 different greenhouse companies now. Okay. To be able to get them to establish in our 2 hydrogen gas sites, because the hydrogen producers have identified them as a great puzzle piece for the cluster.
Okay, yeah. Interesting, thank you. And then, Anna, if we also move further on to what can a research institute contribute when it comes to collaboration here? If you can elaborate on that a little bit, maybe.
Yeah, I think as RISE, we're coordinating this project and trying to establish the ecosystem for establishing bankable or economic viable hydrogen value chains. But I think we're a bit lucky in Sweden as the collaboration culture is quite good. So we have a good start, but we act as an impartial facilitator, trying to speed up the process and bringing even more stakeholders together to also, to, as I mentioned before, to get the systemic change done, as we can only do it together. So I think we will be more powerful, and we will hopefully help to accelerate the transition process.
Great. I don't see any questions here in the chat, but maybe we also, and I think you will also mention that within your presentation about some of the challenges and opportunities that you see by introducing this. And I don't know if you go back to you, Christian, what do you see as the main challenges for you to make it happen? What are the main cost drivers maybe, and then the biggest challenges for scaling up as you see it in most of the cases?
Yeah, I think scaling up to start with is a challenge, and that is something that we are trying to mitigate by taking, let's call, reasonable steps at a time. Our first project was 1 megawatt. Now we're rolling out 10 megawatt projects. We hope to take investment decision on a 100 megawatt project this year. So that is our way, like, of de-risking the process, and that's de-risking for us, but it's also de-risking for our investors. So make sure that our projects are as low risk as possible, as financially interesting as possible, for because raising money is, in the current climate for renewable energy, not always the easiest, unfortunately. I think that we all have seen. So that is one way of de-risking it. Another way of like de-risking is a little bit collaborate with different in different partnerships, and making sure that we're not alone. It's not, as I said, a standalone asset. We are integrated with local stakeholders. We are integrated with the local municipalities to build, or I think a highway project is another good example of that, where we de-risk it through being part of a bigger regional project as well. I mean, that is, I would say, one of the biggest challenges is to get a project to be long-term secure enough to get financial investment. That's, I think, very clear. And then, I mean, another challenge that I think most of us are seeing as well is that this is more or less a brand new value chain that's being built while we're running. So we need all parts of the value chain on board at the same time. And if we take, for example, hydrogen for the transport industry, well, then we need renewable energy. We need to produce hydrogen. We need to distribute that to refueling stations. Then we need someone to buy the trucks to run on hydrogen, and someone wants to be the buyer of these green transport services, basically. All of this is happening at the same time. And if you are missing one piece of that value chain, well, then it comes back to the first point. How do you finance a project like this? It becomes risky immediately. So that is also a very important thing. And it all, once again, comes back to what we all been talking about here today, I think, collaboration and partnership. Like, we can't build our piece of the value chain, sit back and hope that someone else is building their piece without any integration or any partnerships happening. So.
Yeah, great, thank you. And also for the municipality, Matthias, as you, I think you also had a very nice slide showing there the challenges with the grid capacity and land availability. I think you touched as well, but and permits and things like that. So is there some other challenges that you want to mention, emphasize?
as Christian said, I think it's will continue to be risks in this. We feel quite confident that the 2 sites being built in Ånge have kind of solid market demand. The aviation fuel right now looks to be needed from 2030, and the fertilizers, they are needed right now. So that feels okay. And we feel also that our businesses are working with their plans. So I forgot to say that, just to give you an idea of the size of the things happening in Ånge. One of the hydrogen production sites is for 500 megawatts, and the other one is for 300 megawatts. So it's really huge establishments. But the challenge for the municipality, as I said, is to be able to create a community that can attract and welcome up to 2,000 new people within quite a few years. That's our biggest challenge.
Yeah. And then for Anna, what challenges see you from a research institute perspective?
I think I will add the policy. It's nothing new, but stable policy framework I think is really important to get investments and create bankability for these investments. But of course, also the offtake is a challenge. We need secured offtake, but I think most of the challenges were already named, and our goal with this project is, of course, to work actively to overcome these challenges.
Great. I think we are getting closer to 11 o'clock here. So, but if you just could end this with, if you shortly mention the opportunities as you see it from each part here. If we start with Christian, what are the main opportunities with implementing hydrogen in the future as you see it?
Well, I mean, if we can choose one opportunity, I think it is to be locally and regionally supplying our own energy and fuel, and be less dependent on outside forces and imports of fuels and so on. It builds a completely different energy resilience within both local, regional, and on national level, and very clear these days as well.
Yeah. And Matthias?
Well, new industry is almost the only way for a small rural municipality to survive and maybe even to develop. So there's one wing. And then, as Christian once again said, it's about self-sufficiency as well. So those two.
And finally, Anna.
I can only second what Matthias and Christian have already said. I think it's security of supply and resilience come in a lot of different shapes. So I think this is one of the biggest opportunities that green hydrogen production brings along.
Great. And by that said, I want to give a big thank to the speakers. And if you have any further questions, so please contact the speakers. Let's close here. And by that, we want to say thank you from our side, from BIO2REG and RISE, and wish you a pleasant day. Thank you very much.
Thank you very much, and thanks everyone for listening.
Thank you.
Thank you. Bye-bye.